Thank you, Tim, and thank you for having us, Volvo, represented today. I know that people have seen many of the same discussions throughout today, so I will try to keep things moving. There will be a little bit of redundancy, so those slides I'll probably go a little quicker than others. So to get started here, we'd like to discuss the evolutions of the vehicle regulations and how we should be looking forward in those regulations and how they should be developed to be most effective. Some of the background here, of course, we've seen phase two. We have the engines, vehicles, and trailers now regulated. I think it's important to note that we have our dyno tests where we're still regulating in grams per brake horsepower hour. And now we have the GEM fuel map, which is in the gallons per horsepower hour. And I think it's important to note, we are greatly affected by how we're regulated. And unless we look forward into what we want to have the end result, I think we'll be in some ways stuck with what we've got. So it's good to see that the new regulation is focusing on the true fuel consumption of the vehicle. Of course, we have the GEM models, where it takes our input from the engine, and the output is in the grams per ton mile. And of course, we have the fuel economy regulation that NHTSA regulates in the gallons per ton mile. So just stepping forward here, some background, which you've seen the same types of slides. This is probably a helpful slide just to provide a summary of where the reductions are relative to the 2017 regulations through time. Now, of course, we've added the trailers to the regulation, and as you can see, the engines are really significantly impacted by this regulation, as well as the vehicles, but I won't go into the details. I think we've seen these numbers earlier in the day. So just moving on. So I think what's important here is technologies are often applications specific. What one might apply for tractors in the highway may not necessarily be the optimum for the vocational stop and start, and certainly the engine regulation can drive even different technologies. This provides just a summary of the various technologies which are optimized for the various applications. And I think what's an important takeaway is that it's not necessarily the same. So we have to be careful of how the regulations are set up so that we get the right result. As an example, it was mentioned by Southwest Research, Volvo is introducing, well, actually, for the US, we are now introducing turbo compounding. It had been in Europe for some time. And the key here is that turbo compounding, and also with our wave piston combustion efficiency, really optimizes the engine out efficiency. The challenge, however, as was mentioned, when you're optimizing for the engine out, you have to deal with the consequences of a fuel-efficient engine, and that is that the challenge is that the exhaust temperatures are reduced. So you have to manage that reduction in exhaust temperatures, which are detrimental to the after-treatment NOx control, as was mentioned, and this is really what the Southwest Research was focusing on, and how do you manage the after-treatment in the era of high efficiency. And was spoken about in the previous presentation, how do you add energy to your after-treatment to achieve the NOx. And so this is really a good example of how, while you can optimize for the engine, you may not get the optimum system response. And so that's what we'd like to focus on here is, the various trade-offs with the regulations. The classic NOx CO2 trade-off, as you go up, you can improve your fuel economy, but there's the as you go up, you can increase your CO2, but you reduce the NOx, and then the converse as you go down. And as we looked at in the past, when we added EGR, there was a direct penalty associated with fuel economy. And as if you go to more high-risk solutions, you have to manage that trade-off. So this is something that engine and vehicle manufacturers have been dealing with for some time. Now we look at the greenhouse gas. We'd like to look at the advantage of looking at it from a complete vehicle is that you can have what we would refer to as emissions NOx reductions. And these are really not captured very well in the regulation today. Traditionally, we are focused on the engine dyno measurements of NOx per unit work. However, when you can reduce the total amount of work because you have a more aerodynamic vehicle, you can then reduce the NOx inherently by reducing the total work consumption. And this is something that, as we look forward, I think we need to incentivize the complete work reduction. And to that, we'd like to make sure that the inherent NOx reductions are accounted for in the emissions regulations. And this is something that has not been well captured in the regulation to date. So looking at those various technologies, in light of emission NOx impacts, much of the vehicle fuel economy technologies do directly impact the emissions NOx. However, if you look at the engine technology by itself, you may not get the same end result, such as with turbo compounding and improved combustion efficiency do not directly improve your emission NOx. So this is something that, as we look forward to new regulations, just want to be careful, what technologies we're promoting if we're looking at the complete NOx, impact from the NOx inventory. So before greenhouse gas regulations, we focused on meeting the criteria emissions while achieving a competitive fuel economy. Of course, now we have regulated in both the criteria and fuel economy. And, we have to be careful, from the regulatory standpoint, what are the priorities and how do we balance those to the classic NOx CO2 trade-off. And so I think that's an important takeaway here, especially as we look forward to, further NOx reductions and, what is incentivized. So the operating conditions are really important to understand these conditions, from a highway truck to stop and go city driving to the gridlock. This is something that, especially when we talk about the congestion in some metropolitan areas, is not well captured in the current regulation. So to that point, we really need to answer the fundamental question, how effective these solutions are to the market. We may optimize for traditional engine regulation, but we still may not address effectively the heavy traffic situation found in some metropolitan areas. So I think care must be taken to just focus on the traditional NOx standard. I guess we are encouraged to see the amount of work that CARB is doing with a lot of the studies that are ongoing to look at the complete picture. I think going forward, we're hoping that actually results in maybe a new way of looking at these challenges. So many things to consider. we need to be careful not to rush to a simple, one-size-fits-all solution with a regulation. We really should be focusing on the ozone levels of the future. If we are focused on, say, the engine duty cycles, but we increase our congestion on the highways, we really haven't solved the problem. So we need to be focusing on what is the end result. Of course, that goes with this light load and stop and go duty cycles, line haul, regional vocational vehicles. There may be different solutions that are appropriate. And one of the challenges is that we don't necessarily know how a customer is going to use the vehicle when we sell it. And in fact, how does the second customer use the vehicle can have a direct impact on the emissions. Of course, as was mentioned before, the federal and California needs, we need to consider the harmonization. If we need separate regulations, I think, thought needs to be given there on how that can be done in an efficient way so that we can afford to invest in the technologies. As was mentioned, the FTP does not represent a true feasibility for all the applications. In-use limits, the NTE protocol is not necessarily covering all the aspects of in-use testing. And should we consider such things as work-based window or other approaches to be more directly affecting the end result? Something that is a very significant resource consumption for any OEM or engine manufacturer is OBD impacts. As a manufacturer, we can consume considerable resources on OBD, and we just need to make certain that where those resources are put are actually, having a positive impact on the end result. Recognizing that we need to have well-maintained vehicles, but considerable resources are spent with OBD. And then we have to also look at, the measurement accuracy for OBD and deterioration factor, the variability of our sensors and actuators, and very important is the aging characteristics for the complete useful life. And for OBD, you have to demonstrate with useful life hardware. And as a manufacturer, you have to synchronize your DF with that useful life. And it's always a challenge for new technologies, because when you're trying to introduce new technology, at the starting gate, you need to understand its failure modes and how does it react in a useful life manner, 435,000 miles. Unfortunately, that's usually a deterrent for new technologies, but we have to deal with that up front. Again, there are different solutions. We need to be mindful of the cost-effective solutions to achieve the same goal. So, the goal really should be the environmental impact, the inventory of NOx. That should be the end goal. It's not necessarily just to achieve an engine standard. It's what does that engine standard deliver? That's important. In some cases, the situation in some areas, such as in California, are not necessarily representative of the entire nation. So we need to be mindful of how do we address that challenge when we're managing the NOx CO2 regulation. So where do we go from here? We really need to understand what is the problem and focus on the ozone models with the NOx inventory. Need to understand what our inputs are and assumptions for the future. I need to understand the operating modes of the application and the types of testing that are needed to get the right solution. We really advocate looking at the complete vehicle. It's not simply coming out of the engine. We need to look at what's coming out of the tailpipe for that duty cycle. And we need to look at the solutions, of course, that drive a positive win-win for NOx and greenhouse gas. We also need to look at the other impacts, talking about the fleet turnover. The vehicle needs to be acceptable to drive. If we have our stop-start, it needs to be done in a way that is not irritating to the operator. These may seem like trivial issues, but customer acceptance is critical in order to have the volumes of the new technology so that it's meaningful. Of course, the inspection and maintenance programs for the vehicle life. These systems need to be serviceable. Waste heat recovery systems, very interesting in the future, but they need to be serviceable, and it's fairly complex as it is today. So there's a lot to consider with new regulations, and I think from a Volvo perspective, we want to make sure that people are focusing on the true problem and just not a simple solution to say that we've done something. We really want to be solving the problem at the end of the day. And with that, I'd like to thank you.